So one option is it can be 720, and people can choose lower quality if they want, as far as I can see. Choose array, but it's weird that you cannot lower the quality if it's 1080. Anyway. So problem B, which also contained an incorrect checker as far as I can say, as far as I could see. So we have an array A consisting of n integers. Each position I of the array is either locked or unlocked. And we can take values in the unlocked positions. We can take the values of the unlocked positions, rearrange them in any order, and place them back into unlocked positions. And we are not allowed to remove any values, add the new ones or rearrange the locked positions. Okay. And we are allowed to do nothing, obviously. So we can just reorder all the unlocked positions as we want. And now consider the sequence of prefix sums of the array after the arrangement. And let k be the maximum j such that pj is negative. We want to minimize this position. Again, I get yeah, open solution to A. Sorry, again I get some questions. Sorry. Oops. Also the camera. So yeah, this line is what people face. No, student got to mark many countries I visited. In the meantime, you can just send your guesses to the chat, and then we'll see who was the closest. And then locked positions and unlocked positions. We want to rearrange all the unlocked positions to make the last prefix sum, the last negative prefix sum, as far as possible. I mean, sort all increasing all and visit it. At least one, yes, correct. That's a good guess. So we have array A and we have L, which means locked or unlocked. So let's make a vector of all positions which are unlocked. Sort them in decreasing order. And now it's also difficult for us to check the answer, right? Because multiple answers are possible, and yeah, we just cannot really check. But we can always submit. So let's submit and then discuss. Okay, accepted. Hopefully the checker is correct. Yeah, it's a weird problem because it's very easy to guess the solution. You can just try whatever comes to your mind, but then I'm not sure what percent of participants who actually solve this problem could prove their solution or something. I mean, given that also education rounds allow full feedback, but I guess it doesn't matter. Even in a usual code force round, you can expect people to just try whatever comes to their mind and then maybe get accepted if they're lucky. The job of testing system is to test your solution. Just submit. Yes, correct. Okay, so what guesses do we have? We have 100, 50, 20, 38, 17, 12, 15, 16, 12, 21.37, 10, 8, 21, at least 1, 7, at least 6, at least 7, not more than 30. So the solution is just pick all the unlocked positions and sort all the numbers in them in decreasing order, and then just write this number down in this decreasing order in the unlocked positions, right? And that's how we get the answer. But okay, guys, the correct answer is 27, as far as I know. So, in general, all which can never, many people will read it afterwards, but maybe. Okay. So we have n bosses numbered from 1 to n. The type of the ith boss is AI. So each boss is either easy or hard. So we have 0 or 1. Either you or your friend can kill 1 or 2 bosses. Okay. And then my rank does not actually become worse. So, pretty educational, I would say. We have 2 people. Each of them can just kill 1 or 2 bosses, and we want to kill them in exactly the order we are given. And our friend can never kill hard bosses, but he can use skip points for that. And we can kill any boss. So yeah, it feels like a pretty simple DP. So let's see. So again, we have multiple test cases. And we have an array of zeros and ones. So we will do dp. And I would assume there are different ways. But we can do the more straightforward one, which has two arrays. So as I is let's say that him I is the smallest number of skip points required to kill bosses from I to n if it's our friend's turn to move. And as I is all the same if it's our turn to move. All right? Why greedy will not work here? It could be. We'll see. Let's do the DP first. So the DP solution would be we want to find these two functions. So obviously, when we want to kill, let's say that we want to kill bosses from I to n, and let's say we have 0 numbered bosses, so him n and us n is equal to 0, just because to kill an empty set of bosses, we need 0 skip points. And then we go from right to left. And for each position, we want to calculate him I, and then we want to calculate us I. So us I is easier to calculate because we can kill any boss, so we just can kill 1 or 2 of them. And us I will be equal to minimum of him I plus 1 and him I plus 2. But here, if I is equal to n minus 1, we will have an array out of bounds. So to handle it, we can do, I think that the most explicit way, what I would do would be like this. Only update the minimum if we can, if this bound does not go out. But we can do it easily if we just also, actually, we can just increase the size of the array and say that the n plus 1, like for n plus 1, we also have 0, but it's more of a hackier way. So I think that this way is more explicit and better in general. And for him I, it will be us I plus 1 plus, if our friend only kills one boss, we will have to kill, we will have to use a skip point for a hard boss, and hard bosses are denoted by ones, so we just add AI, because we have to add 1 for hard boss and 0 for easy boss. That's exactly the type of the boss. And if again I plus 2 is not greater than n, then we make minimum of us I plus 2 and again plus AI plus 1, because we'll have to kill 2 bosses, I and I plus 1. And so the first person to move is our friend, as you can see. So we just output him of 0, because him of 0 is exactly this situation. Our friend is the next to move, and we want to kill bosses from 0 to n. So I think that should be correct, but we'll see. 2, 2, 2, 2, 1, 0. Looks good. Okay, accepted. Some people wrote about greedy. I'm not sure. What do you... So did anyone have greedy accepted? There is a very easy formula way. You can notice that the answer is just a0 plus sum of lengths of one section divided by 3. Yeah, you can post links. But so I guess that the DP solution is, yes, it's actually the easiest one to just think about, because if the problem allows a simple linear DP solution, then you don't have to come up with any greedy strategies, just because this solution is pretty straightforward in the sense that you just don't need any logical deductions. You just implement what is basically asked. And I think this is quite instructive. But anyway, for some better solutions, it says that I'm not allowed to view the requested page, the page with submission. I'm not sure why that happens. Maybe it's because the contest is not over yet officially. And yeah, for some reason I cannot open your links. Maybe the reason is that, oh, because I am during a virtual contest. Yes, so maybe I can open it in private mode. Yeah, okay. I cheated and open it in private. Okay, so it's A0, because our friend will have to kill the first monster in any case. And then for the rest, we find all the sequences of ones, all the segments of ones, maximal by length, and for each such segment, we just add its length over 3. Is that correct? It would be fun to hack it right now, but really unlikely. Live cheating, yeah, during a virtual contest. So, I mean, in general, it's, I mean, this solution is probably correct, but so, I mean, obviously for a sequence, if everything was just once, then the answer should be the length of the sequence over 3, just because you want to your friend to kill one monster and you will be able to kill 2 monsters, so you just change turns. You kill 1, oh, you kill 2, your friend kills 1, and so on. But count over 3. But it's a bit unclear if how people, like, we have to make sure that we can always be the one to start the segment, right? And given that the lengths we can pick are 1 and 2, it can be proven, but it's not as trivial. Okay, so this is neat, but I would prefer DP over this. But if the problem actually made you to come up with this, then it would probably be a nicer problem. I would prefer a problem which would make you find this solution and not just implement the pretty brainless DP. Yeah, you can always beat 1 or 2 to get the correct parity, I guess. But anyway. Also, I cannot hack it right now because I'm in a virtual context. So test case 011, 011, 011, 0011. I think this solution is correct and it will output 0. Because your friend kills 1, you kill 2, your friend kills 1, you kill 2, and so on. I think this solution is correct. Okay, let's move on to problem D. Vova decided to clean his room. The room can be represented as the... It's a very infinitely long room, but also infinitely thin. We have n piles of trash. Coordinate of the ice pile is IPI. All piles have different, that's important, different coordinates. And the cleanup process is to collect all the piles in no more than 2 different coordinates. Okay. We want to collect the piles so we can move them to some points, right? So in one move, we can choose some x and move all piles from x to x plus 1 or x minus 1. And we can't choose how many piles he will move. Okay, just because we have to move all the piles from that position. And then we also have some queries, which is remove a pile from coordinate x or add the pile to coordinate x. It's possible that there are 0 piles of trash in the room at some moment. And we want to find the minimum number of moves after some queries. Okay, so basically we have to solve the problem. Basically, this could be what I would prefer for the previous problem, but actually, yeah, I just think that you could also add queries to the previous problem to make your solution, like to make people make some additional deductions, but actually people would not make those deductions. They would just do segment 3 DP, and that would be harder to implement, but not a better problem. And here it's a bit similar. So we have some positions. We want to move all the piles into 2 different points, and then we have some changes, and we want to answer the queries after the changes. All right. So there are no pictures, unfortunately, in this problem, but I guess you can imagine. Yeah. So this problem is definitely not as easy. So as of now, as of 43 minutes, we have 1,000 people solving C and 71 solving D. So one obvious thing is that we want to move some, like we want just to sort all the piles by their coordinate and then just choose some position, some border, and then for all the piles to the left of this border, we want to move them to 1 point. And for all the piles to the right of this point, we want to move them to another point. Oh, yeah, I think that should be correct. Just because, like, so we just get all the piles on the left and just move them to 1 point, and get all the piles on the right and move them to the other point. But here, it's important that in one turn we can move all piles from position x to position x plus 1. If in one turn we could just move one pile, then it would be harder, I think. And just because, okay, let's move on to the code. So let's just solve a problem. We have some piles in positions p1 less than p2 less than and so on less than pn, and we want to move all these piles into 1 point. Okay, so if in one move we could only move one pile, then it's a well-known subproblem. We have to pick the middle point p of, okay, let's say that we have 0 indexed positions, and we will just move everything to the middle point. Not the middle point, but the median point. We find the median of our array, and we have to move everything to this position. And the proof of this fact goes like as follows. So just consider all other points. Suppose we move the meeting point anywhere to the right or to the left, and consider how the total distance changes. But this is not what we need here, because actually in one move we can move all piles from x to x plus 1 or x minus 1, and it means that, for example, one way we can do it is just go from left to right and move everything to the rightmost pile. So if in one move we can move all piles from x to x plus 1 or x minus 1, I think that we need exactly pn minus 1 minus p0 steps. And the reason for that is that we can always use exactly this number of steps, just going from left to right. We just choose p0. We move everything from p0 to p0 plus 1. We move everything from that position to the next one, and so on. And we just do a sweep from the left from left to right. But okay, suppose. But then it can be proved that we always need at least this number of steps, because consider the distance from the leftmost pile to the rightmost pile. And initially this distance is exactly this number, and in one step this distance can only decrease by 1, and we want this distance to be equal to 0 eventually. So it means that we need at least this number of steps. So that's why we need exactly this number of steps. And finally, if we want to move everything, like, okay, all piles into 2 points, we have to pick some border position, I. Now we move P0, P1, and so on, Pi minus 1 into 1 point, and Pi plus 1, and so on, Pi minus 1 into another one. And we'll need Pi minus 1 minus P0 plus Pn minus 1 minus Pi steps. And this is equal to Pn minus 1 minus P0. We can write it minus Pi minus Pi minus 1. Okay? So this part does not depend on I, doesn't depend on the choice of our border, but this part does depend on I, and basically it means that to choose the border, we just have to pick 2 consecutive piles which have the maximum distance between them. And we will always draw the border between them. And is it maximum? No, I think it's the total. Not minimum, I think. Yeah. So we just need to find a pair of neighboring piles so that the distance between them is as high as possible. So let's do it. TT will be the number of queries. And what data structures can we use? We can actually use just sets, probably multi-sets. Okay, so we can use just a simple set for all the positions. Let's say it's P, right? And we will also use a multi-set, D, which will be the set of all differences. Pi minus P0, P2 minus P1, and so on. And so initially, we will just, how do you do that? Yeah, so that's what I want. I think that the way to do it is to make 2 functions, which will be add and remove. And so we should add here. So D is the set of differences. So to add, we just insert it here, but we have to be careful. Okay. I'm not sure if there is an easier way, but I think that this way is fine enough. Yes, this should be log n per query. Okay. after we return, it should return a pair, as far as I understand. Let's check. Okay, so insert returns a pair consisting of an iterator and a Boolean value set to true if the insertion took place. So we can assert that we actually added it correctly. But now we know that the iterator is the first element, and if the next element exists, then we have to insert a new difference, and if the previous element exists, we have to insert another difference. And with removing, it will be different. Okay, let's not copy paste too much. So we find our position. So first it will be similar, but here instead of inserting, we will remove, erase, basically. Then we also have to, if both of these conditions are, yeah, so actually here I didn't have to use lower bound. I can just insert and then I can do the same. To make it like, yeah, just use a trip. Maybe it would be easier. Probably not. Yeah, we don't need to use lower bound. And it not equal to p begin. Okay, whatever. I think this should make the code at least somewhat symmetrical. And here we can assert that we have actually found the element. So we insert this difference between next and previous. Yeah, something like that, maybe. Okay, so we have added all the stuff, and now we have to answer a query, and then sometimes we need to make changes. Changes are easier to handle, so we are given t and x. So if t is 0, we have to remove x. Otherwise, we have to add x. And here we need to answer a query. So once again, maximum of p is also, let's check. It's possible that there are 0 piles of trash. Okay, so if let's say the set of differences is empty, then we can just output 0 because the answer is 0. Because we have at most one pile, so it's just 0. And otherwise, we can find the maximum value of p, the minimum value of p, and the maximum difference is here. So we just output max p minus min p minus max d. And maybe this is correct, but I could mess up somewhere. It is not okay. What could that mean? Add I. I don't know why I wrote it like that. 57754849. Okay, lucky me. and 2321000 and a big number. All right, let's submit. Okay, accepted. Oh, I missed a raid from Grave K pair. Hello. Sorry for missing it. I was a bit busy with the problem, but good to see you. So yeah, once again, so after we figure out the formula, it's easy if we maintain two sets, the set of all positions and the set of all differences. But then the biggest question is how do we quickly update these sets? So these functions are a bit tricky, and they are the hard one, the hardest part of this solution. Does anyone have a better idea on how to implement this? Right, because you haven't solved E, F, G. Okay. So if there are no questions about D, then I should be moving to the next problem. Maybe I can solve them.